Hey Connor, this is Mrs. Bird. I am looking at your 14.1 workbook. I'm going to look at questions 1 and 2 here with you. Ironically, you were probably about the 4th or 5th student to ask me about these two specific problems. So you're in good company, and I forgot to get my pen up. There it is. Okay. So I'm sharing split screen here so that you can see the question over here, and I'll do the work over here on this document that I'm just going to use as a white page. All right, so I know that I have a triangle. Little tip about geometry: when in doubt, draw it out. So I'm going to literally draw a very horrible triangle. Nothing fancy here. Bloop, bloop, bloop. Okay, so I'm going to label this triangle ABC. This way I just visualize things because I'm a very visual person, maybe you are, but it also really helps my brain kind of take the words and kind of see it in an application. Okay, so here are all my angle measurements. It said that A was 3x, B was x plus 5, and C is x minus 15. Now, we don't know what the actual measurement lengths or measurements are for any of these angles because we don't know what x is. If we did, if x were equal to 2, for example, then we could very easily figure out the measurement of angle A because then we could just say, it's 3 times 2 using that substitution, right? We don't know what x is right now, so that's going to be part of this problem is solving for x to find that angle measurement that they ask us. So first it asks us which one has the largest angle measure. Well, we can actually solve that just by using a little bit of logic. I have the same variable x in all of these, so it has to be the same number. So think about what's going to produce the biggest angle measurement. If I take a number and multiply it by 3, that would be angle A's situation. Or if I take that same number and add 5 to it. Or if I take that same number and subtract 15 to it. So I'm not going to answer that for you, but that should be a very good, strong suggestion on what that first blank part is right here, that first blank. And then we have to actually find what that largest angle measure is, which means that we have to solve for x, as I said. So the great thing about my diagram here is that I'm noticing that I know a little bit of information about all 3 of these angles. And I know that from some of my postulates in geometry that all 3 angle measures have to sum, not sun, 180 degrees. So that means that if I took measurement of angle A, which is 3x, and I added that to the measurement of angle B, which is x plus 5, and I added that again to the angle measurement of C, which is x minus 15, that all has to sum up to equal 180 degrees. I wrote 180 on the left just because I was running out of room. Okay, so from here, I can simplify. I know that 3x is like terms with x and this x, so I have 180, which is equal, let's see, x plus 4x, 5x. I can count. And then I have a positive 5 and then a negative 15. Don't forget that negative there to be a minus 10. Add 10. And then I do have a calculator here. Maybe your brain works a little bit better than mine first thing in the morning, but we're going to divide. So 190 divided by 5, 38. X is equal to 38. So what you want to do is take that x value and you want to use that substitution rule, just as I said earlier, into whichever one of these angles you concluded to be the largest angle measure. Which one of these are going to be the biggest angle? Okay, so hopefully that walks you through question number 1. I'm going to delete all of this so that we can look at question number 2. Now, question number 2 is about an isosceles triangle. Now, I do know a little bit about isosceles triangles. I know that 2 sides are the same measurement. right? So I got two sides of the same measurement, which also means that two angles, those two base angles, have to be the same measurement. So that is my definition of an isosceles triangle. So I'm going to use that definition to kind of work off that I know that AB is the same as AC. So remember, when in doubt, draw it out, because that's going to give us a lot of information. In my drawing, I cannot just label it as A, B, C. Normally I would like to have, but remember, I need AB, so this guy, to be the same as AC, which is not how I drew my triangle. So that means that I need to swap around my labeling a little bit. C needs to be here. B needs to be here. So now I have AB congruent to AC. So now the wording is matching up with my diagram. Now, the reason why that's really, really important is because I know that measurement of angle A is 2x minus 20. So I'm going to label that here. And I know that the measurement of angle B is 3x plus. Did I label these wrong? I totally did. Oh, snap. Okay. AB, I did AC and CB, didn't I? Ha, ha, ha. Okay. See, that's why the labeling is really important. Ironically, okay. Let's see. So I have AB and AC. You know what? A needs to be up top, doesn't it? All right, you saw me make a mistake. No big deal. So now I'll just correct my mistake, right? 2x minus 20. You were probably looking at my you're like, Miss Bird, those things aren't congruent. You're saying that they are, but they're not. Okay. Thanks for staying with me. So I got AB is congruent to AC. Measurement of angle A that I have written in yellow is 2x minus 20. Don't know what the actual number is because I don't know what x is. But I do know the measurement of angle B to be 3x plus 5. Now, because of my drawing, I also know the measurement of angle C, because remember our definition of isosceles, those two base angles have to be the same. So that is why I really love drawing the triangle, because I would have missed that piece of information had I not seen that B and C were the same angle measurements. Okay, so from there, we're going to do the exact same thing that we did in question 1. And we're going to use this idea that these three angles, measurement of angle A, adding with B, adding, so this is A, this is B, and then adding with C, 3x plus 5, sum to be 180 degrees. And then we are going to simplify, solve for x, and then use that substitution to plug it back in for angle C. All right. Yeah, so this is why it's not just 3x plus 5. We have to use this formula here, solve for x, and then use that substitution back in there. So you're on the right track. You knew about the isosceles triangle bit, but just needed that solving piece as well. All right, Connor, thanks for reaching out to me, and I hope you have an amazing day.